Today we're going to look at curved graphs. Curved graphs, basically all the graphs you need to know for GCSE. You might have seen in your mocks, you have these questions where they give you like 4 graphs and then you have to say which equation matches the graph in the table. So like A is this graph and B is this graph, etc. So if you've done some mocks, which most of you will have, you will know what kind of questions I'm on about. So what we're going to do is we're going to be very clear about what equations match what graphs, so that when you do come to those questions, you'll know exactly which one's which. Yeah. Starting off with the nice and simple ones, linear graphs. Yeah. So just lines. Now we should know we are going to do lines properly um, in a future lesson, but we should all know that lines are in the form of y equals ax plus b. I mean, we learn a lot of the times y equals mx plus c, but we're going to, a and b are going to be common constants throughout this lesson. Lines are in the form of y equals ax plus b. So the number in front of x always represents the gradient of the line. Remember, gradient means steepness. Now, the number at the end, always remember this, the number at the end that's independent of x meaning it doesn't have any x next to it, is always the y-intercept. So what I'm saying is, what does a line look like with a being bigger than 0? Remember, a is the gradient. So if a is bigger than 0, we're saying the gradient is positive, meaning it's an upward sloping graph. Yeah, it's an upward sloping line. It'll look something like this. Yeah. So this is y equals ax plus b, with a being positive. Yeah. Now remember what I said, the plus b tells you where it crosses the y-axis. So here it crosses the y-axis at b. In this situation, I'm obviously implying b is positive, but it could have looked like this, and this would have been if b is negative. Yeah, so if b is positive, it would have crossed the positive y-axis. Then if b was negative, it would have crossed the y-axis in the negative plane. Yeah. The next one is the same line, but when a is less than 0. A is less than 0 means negative gradient, downward sloping. So look exactly the same, but downward sloping like this. I remember right now I'm only interested in the shape. Yeah. Here, that would be if b was positive. Yeah, it would cross the y-axis on the positive y, but still negative gradient, downward sloping. If b was negative, it would point downwards like that. B is less than 0. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. The next one is quadratics. Now, next lesson, we're going to do a lot more on sketching quadratics, but quadratics are like the smiley face. That's usually how we learn in year 7, right? Or an upside down face. Now, if a is positive, yeah, if a is positive, yeah, if this number here is a positive number, it's a smiley face. Now remember, the number independent of x, which is this plus c, tells you where it crosses the y-axis. Now I'm not going to specify here whether c is positive or negative. I'm just going to draw any old quadratic. So here you could just put any old smiley face, yeah, and it would cross here at whatever c is. In this case, in terms of my drawing, c would have to be negative. Yeah. So in terms of my drawing there, c would be negative because it's crossing the y-axis in the negative plane. Yeah. The next one is if a is negative. Yeah. If the coefficient of x squared is negative, then it will be that frown. Yeah. So look more like this. And it would cross here again at c. But in that case, c would be positive. Yeah. Right, the next one is cubics. Now, cubics do have a few forms, and you guys need to be aware of what those forms are. But the most basic positive cubic looks like this. comes up, then it goes flat at 0. So you want to make it look like it goes flat, and then it keeps going back up. Yeah. This is a positive cubic. Yeah, when the a value is positive. So examples, y equals x cubed would look like this. Y equals 2x cubed. Y equals 3x cubed. As long as the coefficient of x cubed is positive, that is what the cubic would look like. The next one is if a is negative. If a is negative, it does the exact same shape, it's just the other way around. Very important, with cubics, and if you guys decide to do A-level maths, which would be fantastic, you learn more about what the cubics will look like properly because there are variations to cubics. A way to remember is that a quadratic has what we call a turning point, which you might have learned in school. Now, a quadratic has one turning point because you can remember that a quadratic is x squared. To find out how many turning points it has, you do the power minus 1. So 2 minus 1 is 1. So quadratic has one turning point. Cubic is power 3, meaning you do 3 minus 1 is 2. So it has two turning points potentially. Yeah. A curve that has two turning points basically looks like this. There's one turning point there and one turning point there. So just remember the rule. You do the highest power, subtract 1 equals number of turning points. Here, in terms of when a is positive, it still has to come from below and up. Yeah, just like here, can you see it comes from below and then goes up? It does the same thing. It's just, it goes from below, it can have two turning points and then back up. For cubics, I think of Drake's song, started from the bottom now. Started from the bottom. Let me change that. Started from the bottom. You lot can rap this with me, yeah? Starting from the bottom. Now we here. That's positive. If you start from the bottom and then you end up at the top, that's a good thing, right? That's positive. So the other one looks exactly the same. But remember, we start from the top and then we end up at the bottom. Yeah, just make sure it has two turning points, that's all. Yeah. So far, we've done all the basic graphs. We've done the linear graphs, the quadratics, and the cubics. We do not need to go to quartics, power 4. Yeah, that's not in the spec. That is A-level stuff. The next one is reciprocal graphs. Yeah, reciprocal graphs, for example, A over X. Yeah. Now, the way these look is, the way you think of it is, it's a division, right? You're doing a number divided by X. Now, X is something that can keep changing, right? Think about it like this. If you increase the value of X, yeah, if you make the denominator bigger, 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 if you do this division and you keep making the denominator bigger, will the overall number get bigger or smaller? So if you keep making X get bigger, 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 you're making the denominator bigger, 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 will the overall number get bigger or smaller? The number is going to get smaller. So say I'm here. As I increase the X value, the overall function is going to get smaller. And then we could say it the other way. If X gets smaller, then the overall fraction is going to get bigger. So it's going to look like this. It's going to keep going up like that. Then on the other side, if X is negative, then the division is just negative. So it would look like this. Yeah. Now, very simply, when we look at y equals a over x when a is a negative number, it looks exactly the same. It just goes in the opposite two quadrants. So positive quadratics are always in quadrants 1 and 3. For negative reciprocal graphs, it's always in quadrants 2 and 4. Yeah, the quadrants go like this: 1, 2, 3, 4 in maths. So always remember, positive reciprocal graphs are in quadrants 1 and 3. The negative reciprocal graphs are always in 2 and 4. And with the negative one, the asymptotes are still the same. It's all the same. It's just remember which quadrants. They're always in opposite quadrants. Yeah. If you ever see a graph where they're both in like 1 and 2, that would not be a reciprocal graph. That could be 1 over x squared, but you don't need to worry about that. If they ever give you 1 over x squared, then by elimination, you'll know which ones are definitely the graphs given. But then by elimination, I'll show you it anyway. 1 over x squared, just for your guys' interest, looks like this. So maybe you want to make an extra note. That's what 1 over x squared looks like. And it has the same asymptotes at x is 0 and y is 0.